Solutions to the Chapter 1 practice test are as follows. This is number 11 from the free response. And as you can see with this, it was what percent of the data of people in several age groups who attended a movie. So here's the information, and we were told that we need to display these data in a bar graph. All right, so there's my bar graph. To have an adequate bar graph, you need to have a label for what this is on your x-axis, age. You do not need to necessarily label all of the data points, but enough to show the reader, which is me, what that corresponds to. And then some labels over here. What I probably should have also had on here, and let me just draw it in quick, would be that number right there, which is 83%. Just enough to show me, the grader, the reader, hey, here's all the data, here's how I put it in my graph, and then it goes on up from 18 to 24 up to this last one, which was 75 years plus. And that would be enough. You don't need to give it a title, but you do need to have numbers and a label. Numbers and a label, there's my label as percent, and something here and here that tells you these are the values that correspond to it. And that would be enough to get full credit. Full credit will be given in terms of either an I, a P, or an E. I stands for incomplete or inadequate. P stands for partial, and E stands for essentially correct. All right, so for that graph, to do what I did there would be essentially correct. If you had not listed these things across the bottom, you'd probably get a P. If you just had the graph with no labels and no numbers, it would probably be an I. And I'll show you how those all come together at the end for an overall score. And then it asks these questions. Display these data in a bar graph. And then what's the main feature of the data? So these actually will go together before I can give you the E. All right? The main feature just means what is at first glance, what do you notice? As age increases, the percent of those who attended a movie decreases. Try as you might to always use context. Percent of several age groups who attended movie in the last 12 months. So bring that into what you're doing. If you only say the graph decreases, that would be partial. All right. If you make no indication of anything going on, that's incomplete. Or you make a wrong statement, that's also incomplete. What if I said, as age increases, the percentage of those who attend decreases, but then you said something else that was wrong? I grade, and the AP exam is graded by taking the less right answer and grading that. So there are some people who in their history of taking tests try to write down everything possible that they know. If you write down, let's say there's 4 things that you write down and one of them is completely wrong, you are graded on that wrong one, not on the other 3 right ones. So it's an element of write down what you know, but do not be too verbose. All right, don't just vomit on the page and give me everything that you've ever learned, because some of it might be wrong. And usually, good rule of thumb is, look how much space they give you. If that's not enough space, you're probably writing too much. Would it be correct to make a pie chart of these data? No, it is not correct to make a pie chart of these data, because each percent is of that age group, not of a whole population. So this 83% is only of those that are between 18 and 24 years old. It's not 83% of everybody that they talk to. It's only 83% of those in that age group. Additionally, if you look at the percentages right here, they do not add up to 100%. So you cannot use a pie chart if it's adding. But beware, the way that AP exam questions might be to be tricky is they might make these actually add up to 100%. The answer would still be no, because each percent here corresponds only to percent of people interviewed in that age group. You know that because it says, here are the data in percents of people in several age groups, not of an entire sample or of an entire population. All right. So not indicating that, first, if you don't answer yes or no, the best you could get would be a partial. If your explanation is right, but you didn't say no, it's a partial. You have to answer the question. If you answer no and provide no explanation, it's an I for incomplete, because then all I'm assuming is you're guessing. So there needs to be an explanation. So this one also, because I did it and I know what I'm doing, is an E for essentially correct. And then lastly, we have a movie studio wants to know what % of the total total audience for movies is 18 to 24 years old. Explain why these data do not answer the question. That is actually very similar to part B. All right. Explain why these data do not answer this question. All right. I wrote, we only know that 83% of those in that age group saw a movie. We cannot tell how many are how many are in any of the age groups. So we cannot tell. They want to know what % of the total audience for movies is in this age group. 1, we do not know how many 18 to 24-year-olds were asked. 2, we do not know how many total people were asked either. So we cannot determine the percentage of those in this age group. Okay. The way I have it phrased here would be an argumentative, either a P or an E. My verbal explanation was better than what I wrote, but for argument's sake, for showing you what to do and how I grade these things, that's why I put that on there. I would say argumentative, all the graders would sit down and they would discuss and debate and whether or not this would be determined to be a P or an E. In this case, they would likely score it as an E. And then how this overall scores for a test question is I would look at this and say there were 3 parts. There was part A, B, and C. It was scored as an E, which would be full credit, which is a 4. Let's say we had said, oh no, that last one was actually a P. If that's the case, then this isn't a 4, it's a 3. What do the 4s and the 3s mean? In the land of AP, it means a lot. For how it means to us in our classroom, it means that a 3 is a B. Just like on a grade point scale. A 4 is an A. All right. And that's how I score and grade all of the questions. It's more of a holistic look. All right. So overall, you could have some minor pieces, and this one's only a 3-part question. You can have some 4-part questions where it's possible that it will be an EEEP for a 4-part question, in which case then that would go back up to a 4, which is in A. So it's all going to depend on the question at hand and how it all gets scored out. Number 12 says here's a histogram of the number of unprovoked attacks by alligators. I'm not sure if they actually keep track of provoked attacks by alligators, and then just call them stupid people. But unprovoked attacks by alligators on people in Florida over a 33-year period. I circled the number 33 and indicated that, what did I indicate there? I can't read it. Oh, I know. That the median value is the 17th data point. Because I looked at said 33, okay, half of 33 is 16 and a half, so up to 17. The 17th data point, lowest to highest, the 17th data point is the median value. Why is that important? Because I'm likely going to be asked to describe this data set, which includes shape, center, spread, and any outliers. Every time we are asked to describe a graph, those are the 4 words we have to be thinking of every single time. All right, and lo and behold, part B gets that. So part A says, what's the overall shape of the distribution? All right, let's take a look at that. Overall shape looks to me to be slightly right skewed. So I wrote, the graph appears to be slightly right skewed. Definitely not mound shaped. It's definitely not bimodal. Some people would argue and say, well, what about it? You know, it kind of goes up and then down and then up and then down and up and then down and up and then down. Don't look so finely at the details. Kind of skim over it like you do in English class, you know. Just skim over it and get a general sense for what's going on, and it's slightly right skewed. And now you're all admiring my great skills at being able to manipulate graphs. But there we go. Part B says, what's the approximate median? Now, I like the fact that the question asks for the median, but don't assume that that question, a better question would have been for part B, what's the approximate center of the yearly counts of alligator attacks? And then they expect you to know, as the great statistical student that you are, that the middle value in a case like this can only be talking about the median. Why do I not know the mean? Because I do not know every data point. And also, let's zoom in here again. It tells me the count and the midpoint for each bar. So what I started drawing in there is, well, if the midpoint is 2, that means the endpoints were 1 and 3, then 3 and 5, and then 5 and 7, then 7 and 9, and 9 and 11. I'm trying to make sense of what this data is corresponding to what the graph shows. Second thing I need to figure out is, what does that mean? Count 2. That means that this one is 2. And this next one is 4. And that's what each of them are as I go along there. And if I want to, I can continue to write them in. 8, and then the next one's 0. And then after that I've got 4, and then 2, and then 5, and you get my point. Do you have to write that on there? No, but I'm doing it because to find the median, remember I'm looking for the 17th data point. 17th data point. Well, here I have 2. Here I've got 4 more, so now I have 6 total. Then I have 8 more. Okay, 6 and 8 is 14. All right, and then I got nothing. So I'm still at 14 data points, and then I have 4. Now I've got 18 data points. I have 18 data points, so the median is somewhere in this bar. It's one of those values between 9 and 11. So what would be a good guess? That was a long enough pause for you, so we're looking at that and saying, okay, it's somewhere in this zone, somewhere between 9 and 11. Don't overthink it. Don't say, well, there's 4 data points, and one of them is in there, so I'll go from 9 to 11 and break that into quarters and then add it up. It's either going to be the number, and because look at this. This tells you that it's not actually 9 to including 11. It's either 9 and 10, because it does not include the top number. So this bar here actually is 9 or 10. So it's either going to be 9 or 10. I'm going to guess 10 because that's the midpoint number. So my response would be the 17th data point, which is the median, is in the 9 through 11 bar. So I would expect the median to be 10 attacks. The question was just asked, how important is it that we use whole sentences? And the answer is fairly important. I say use complete sentences only because that's a good way to remember that you need to have a complete thought. Incomplete thoughts leave me, the reader, and the grader to try to put and fill in the blanks, and we're taught and trained not to do that. So as we're grading your exams, we're taught not to infer what you might be writing about. If I have to guess, I have to train myself to guess the wrong answer. So if you want to be a complete thought, then write a complete sentence. If it's an incomplete sentence and an incomplete thought, you're left with hoping that I can assume I know what you're talking about. And generally speaking, I don't want to ever be able to read your mind. You probably don't want me to read your mind. And so as I'm grading, I will try not to read your mind and infer what it was that you were trying to talk about. So when you're doing this, like on letter B, how much do I actually have to write? Write a complete sentence. That way you're not caught off guard by not having a complete thought. Then part C is this time plot for the alligator data. All right. Much of the time when they add a secondary graph, they're really going to try to confuse you by creating different things that you may not have seen before. Like instead of using the year 1972, they say, well, the number 1 represents 1972. And the number 33 represents the year 2004. So as you're looking at this, you go, okay, well, let's see, 33 is about there, corresponds to this 1. All right, which means what? Well, over here it's the number of attacks. And you've got this going on, and so it says connect the numbers from 1 to 8 4 times, then 1. Connect the numbers from 1 to 8 4 times, and then 1. And you have to think to yourself. So. Thank you. Class is participating. What does that mean? So let's take a look at that. It is essentially a connect the dots activity. So I'm going to kind of zoom in here so I can do it better with my finger that I'm drawing with. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. And finally, 1, 2, 3, 4, 5, 6, 7, 8. It asked me to do it 4 times, which you can see I did it once, twice, 3 times, 4 times. So I connected the data in order, 1, 2, 3, 4, 5, 6, 7, 8, and then I have this last little one out here, which don't worry about, because it only said to do it 4 times. What overall pattern does this plot show? When you're doing it, what I actually have here, both an overall graph and 4 individual graphs. All right, what do we notice? 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Notice with the inflection of my voice, within each set, except for the last one, there's almost like a consistent pattern with the 1, 2, 3, 4, 5. Almost, I said. With a peak in either the 7 or the 8 year for number of attacks. See, look at that, it goes across 22.5. Whatever that number is. Whatever that number is. This 5 has a big peak. So it looks like they're low, there's a peak here, and then it goes down. There's some low, and then a peak here, and then it goes down. All right, but overall, what do we see? Overall, the trend seems to be going up. So does there appear to be maybe an 8-year cycle? Possibly. Overall, the number of attacks over the years from 1972 to 2004 have, on average, been going up. Granted, there's some peaks and valleys. All right, and then you go along. So part D asks, so what do I actually write for what is the overall pattern of this data? The data appears to have an increasing or a positive trend, which means, okay, again, that phrase, use it often, which means, because that's your linkage back to context, which means as the years go up, the number of alligator attacks also goes up. There's a lot of variation, again, overall pattern, shape, center, spread, outliers. It's another way of saying describe the graph. Increasing. There's a lot of variability as the numbers jump up and down for number of attacks. Looks like there's an unusual peak in the year 6, and the year 7, and the year 7, and in the year 5 as you're looking at the data. So a lot of variation as they go up and down, but peaks at those values. Center. There isn't a great way to describe center, which gets to part D. Why is the typical number of attacks from 72 to 2004 not very useful? Well, because a typical value is probably going to be somewhere, because look at all this variation, it's probably going to be somewhere right around here for total number of attacks. Why is that not useful? Well, because the average is being held low by all these low numbers. All right, even though there were some high values here, there's a lot of years that had low values. So an average is going to be lower than maybe what you currently expect. Especially the question says in 2006. 1, the last data point is 2004. We have no idea what, or actually 2005. No, 2004, sorry, 2004. So we have no idea what 2005 or 2006 is going to do. Part D says, why is the typical number of attacks for 1972 to 2004 not very useful? Well, it's because it's outside of the range of values as I go to 2006. I have no idea what's going to happen in 2006. I might be able to predict what's going to happen, but probably not very well, because look at all this variability. The numbers jump up and down. All right? The fancy statistical term that we'll talk about later is extrapolate. Extrapolate. It means to go beyond the values of the data set, beyond 2004, and make a prediction. Extra, outside, polate, to predict. All right? We don't do that. We can only talk about what happens within a data set. Anything outside of 2004 is extrapolating, and extrapolating is bad. Everybody say that. Extrapolating is? Bad. Bad. Thank you. That goes for the solutions that I'm going to show you. I'm not going to show you number 13 right now. This video is plenty long as it is. We'll see you when you get back.